density equals mass over volume. And it says, what is the density of a 50-gram box? 50 grams, is that mass or volume?
Mass.
Mass. So we're gonna divide it by, and I'm writing it how you can type it in on your computer. 5 centimeters by 2 centimeters by 4. How am I gonna get the volume?
5 times 2 times 4.
All right, so before we do that, we need to do 5 times 2 times 4. What does that equal? 5 times 2 is 10, 10 times 4 is 40. So 40 centimeters cubed. So we have our volume. Now we're gonna do density, 50 divided by 40. That is going to be 1 1/5, but I'm not sure what the decimal is when it's, was it 1.2? 50 divided by,
1.25.
thank you, 1.25 grams per centimeter cubed. So this is what you type in for number 1. And I sort of did it as a, long row. Remember, so right here, this little t to the squared right here will let you put in a exponent. So v equals 5.
I think it says T. Will you find it?
2x4 equals 40 cm, and you should be able to go here and do a 3, and then you click off of it, and then you can enter, or you can just space some more and do d equals 50/40 for divide equals 1.25 centimeters. Click on that T with the little 2, a 3, click on it again, and there's 1. So that's how you can type that in. All right, now, does anybody know the density of
You
water?
put your gram.
Oh, thank you. Thank you. All right, does anybody know the density of water? All right, water's density is 1.0 grams per centimeter cubed. All right, if an object is less than 1 in density, is it going to float or sink? Less. Float. If it's equal to it, it'll kind of be half in, half out of the water, but still floating. If it is greater than 1, it is going to sink. So this says, what would the cube in number 1 float in water? So look at this number. Is it greater than 1?
Yes.
Yes. So you would say that it would not float, it would sink. So, or you could say, no, it will not float because its density is greater than water. Then there is one more density problem. And those that were here, I showed a triangle method. Right here, you can put your formula in, oops. All right, and so if I was looking for density, I cover up the D and I see it's mass over volume. If I want volume, it's mass over density. And if I want mass, it's density times volume. So here, an object with a density of 6, so I'm given density, is placed in a graduated cylinder with 15 milliliters of water. When added, the water rises to 23. Find the mass. We have to find the volume first. What am I going to do with those two graduated cylinder measurements? Not add, but subtract. So I'm going to take 23. So for this one, we're going to do 23 minus 15. And what is that? 8. It's 8 milliliters. All right, then I want to find mass. So if I come up here, it is density times volume. So I'm going to say mass equals, my density is 6 times my 8. That is 48, and it'll be grams. So what you're going to type in is kind of what I wrote there with this drawing out marker there. So for number 3, you're going to put volume equals 23, minus 15 equals 8 milliliters. Oops. Then I'm going to say mass equals 6 times 8 equals 48, and mass is always in grams. And then you will submit it. So you can go to PowerPoint, and I'm having the hardest thing on it.
So we submit it after that?
Yeah, go ahead and submit it. I was leaving in case somebody needed to see it. And then. All right, while I'm trying to find this, I want you guys to go to modules. And we're going to clarify your work on Friday. Remember, on Fridays, you must complete work. The work, something has to be submitted by 2:30 in order for you to be counted present on Fridays. So just a reminder. And on Friday, just to look, you had an online density activity to work on, and you had this plasma games assignment. Now, I know Austin, I got you in, right, the last time you were here. I think we got you in. So if you haven't, Amaya and Ricky, if you haven't gotten in, I want you to click here. And let me get out of student view so you can see it. Your code is going to be this one in the green here. I have it written up on the board up there. It starts with the AQ. You're going to log in to play.plasma.games/login, and you're going to start with number 4 here. So you're going to get this screen, and I need you to sign up for an account. And notice, I want you to use your first part of your email for your username. and the password that goes with your email. So if y'all get that set up while I am looking for my PowerPoint that just kind of moved and disappeared. Yeah, you're a student, so you're gonna click on the student, put the first part of your email, so the first three of your first.
For my username,
Yeah,
Okay.
and then the last, just like your school, there you go. And make sure if you capitalize it or whatever, if you remember what it is. That'll help me be able to recognize you when I go into the teacher side.
That's the class code?
Yeah. Make sure if it's capital, you put it in whatever, and then use the same password with your email. And on Fridays, you're gonna be required to, play in this game here as a part of your assignment.
What's the name? Happy teacher.
Oh, okay, you're gonna type whatever they say here, so that's gonna be a little R, a
Oh,
little
okay.
T. And then,
Four, T.
and that. And, what is wrong? But then you enter everything again.
Yeah.
Alright, so,
Capital A.
capital A, Q, M, F, capital C, capital U,
Oh, that's a capital U.
yeah, little k, capital U. And then add your stuff back in. Okay, I found, yes. Oh, it's called states.
This is science, global.
Yeah, all right, hold on. Back to where we was at. All right, and what you'll do on Fridays is you would go here, and it's like a video game. And I haven't figured out exactly, and those of you that actually do gaming, you may be able to help me here. I think it is set up in episodes, and within each episode, there are individual levels. So when I played it as a student, I got up through level 3, and when I went to click out, it said it wouldn't save. And then when I went in the teacher side, it showed me how long I was on there, but it said nothing was completed. So I'm thinking you may have to complete the episode for it
Possibly.
to register on my end. And I don't know how many levels are in an episode, so we're just gonna have to play around. It's something new we got a grant for. It does, it has science, physical science concepts in it. And the first thing and it takes a while to load the first time, it will give you, get this PowerPoint. The first thing that it's going to teach you is about phase graphs, things changing from liquids to gases, solids, liquid, gases, which we're going to talk about today. So that will be I can get this to get where it needs to be. I won't have the PowerPoint on your computer, so you'll have to follow along up here. but at least I will have it where I can add it right after class. Yeah, and, so it's very new, and if you're comfortable with gaming, you don't have to, I chose the very first one because I don't do gaming. And, it helps a little bit. You can choose different levels. Hold on just a minute. Don't matter, I'm going to stick to the next. There we go. All right. So on your notes, you have the Canby if you're doing it online. If you have paper, you have the paper copy. If you're doing it on paper, you may want to go ahead and submit that on the computer so it doesn't show up as missing. And then I will put the grade in when I collect this.
So you just submit it?
You'll submit a blank one on the computer, just submit the CAMI, and then I'll use this as your grade.
Oh,
That way it doesn't pop up as late. Does that make sense?
Yeah.
All right. So we're going to go ahead and put this A, capital A, lowercase q, lowercase. Oh, here's G, I think.
That's cute.
No, I want to make sure. Okay. Thank you, M, F, capital C, capital U, K, capital. Oh, from the other thing, okay. Now, put the first part of your school email. And then use the password for that email.
I'm getting $10 today.
You have to put it twice.
I'm getting $10 today. Me and my boyfriend made a bet. I'm getting $10 because he was like,
All right, now the capital.
if I don't put it for February 1st, I gotta give you
April the 1st?
February.
Oh,
So today, if you don't do it today, I get $10. He's not gonna quit. I told you.
and so that's where you there, so I'm assuming for it to show up,
Wait,
I can't see how long you've
His
been
job.
on it, they won't register, you completed something until.
Why you gotta put his job?
Cause he don't like it.
This is
Where's
our
your work
Friday,
at?
part of our Friday work.
And plus they gonna bake ribs.
All right. States of matter, so this is probably a review. Everybody understands that matter goes through changes and from solids, liquids to gases. And so we're gonna do a quick review. Thermal energy is if you take all of the energy of each individual particle that's in matter and you add it up, this is thermal energy. Particles, even in a solid, are actually moving, so there's some energy in there. And so that's what thermal energy is. We also look at it as heat energy. Just to review, kinetic energy is going to be energy in motion. So if something is moving, even solids vibrate a little bit, they're going to have some kinetic energy. Potential energy is stored energy, and there's several different types of potential energy. And so when energy is stored, so if a ball is sitting at the top of a hill, it's got stored potential energy. As soon as it starts rolling, then that's being changed into kinetic energy. And so this is going to relate to how matter goes through physical changes. So we should, and we have a theory that's going to explain what we know that's true about this. Is everybody good?
Yeah.
All right, kinetic energy or molecular theory. Molecular comes from the word molecule. So all matter is made up of either atoms or molecules. And these small particles are going to be in constant motion. And it's going to be random. So these are the three parts of this theory. So all matter is made up of small particles. We're meaning atoms or molecules or compounds. And these particles are going to be in constant motion. And the motion is going to cause these particles to collide in whatever container they are in. And so a solid has very little motion. They're just vibrating. A liquid, they have more motion. And a gas, they have a lot of motion.
Mr. Moore, I didn't get any of that.
Well, he
You want
does.
me to just go back?
That's not on there yet. I'll go
Okay.
back in a minute. Let me get through these and we'll go back in a minute.
These are on here.
Okay. All right, thank you.
I'm gonna have it up. I just don't have it because it disappeared out of my drive.
It's okay.
I had to download it again.
All right, thank you.
All right, so temperature. This is how we measure this kinetic energy. And so we think of temperature as just how hot or cold something is, but in scientific terms, it is actually the average kinetic energy of the particles. So if we would take the kinetic energy of every particle that is in a substance and average it together, that is temperature. And so we use a thermometer to measure this. And so the higher the temperature, that means the higher the kinetic energy. There's more motion going on with those particles. And so how is this going to connect with states of matter? Well, this is going to be how we get from one state to the other. We're going to have some temperature increases or decreases that's going to cause the change of this.
Hold on a second.
And there's nothing to do with these questions here.
Nope. Great.
Fine. All right. So here's the three states of matter. We've got solid in the cube, in the cylinder, that's a liquid, and then in the container with the cork, that is a gas. So that's what it's representing. So we're going to talk about solids first. So this should be a review from way back in elementary school. Fixed volume and fixed shape. Volume and shape, unless you do something to the solid, it is not going to change. Yeah, you can keep your papers in it here. And then I'll punch holes in it when we're done. So these particles in a solid are going to be held tightly together. So the structure is going to be what we call rigid. They're going to have very low kinetic energy. They're still going to move, they vibrate, but it's not a lot of movement, so it's going to be low kinetic energy. So anytime you see a diagram like either one of these, we're representing a solid. Is everybody with me there? That all the way down? So we can flip to the next page. Good, Ricky? All right, liquids. Notice how there's a little more space in between these. The volume is fixed. So you have a set volume, but the shape is going to change depending on what container it's in. There's gonna be more kinetic energy than solids, and notice they're not, there's space in between it, it's not a set rigid pattern, they can move a little more freely. And so we call their movement kind of a flow or slide past, they can flow or slide past one another. And so that's how we look at liquids.
It's still smart, good.
I got those. Gas, if you notice, gas doesn't have a fixed volume or shape because they're going to spread out, and unless they're in a container, they're going to keep spreading out. And this spreading out, we have a name called diffusion because it's going from an area where there's a lot of them to an area where there is little, where there's none of the material. And so it's going to have even more kinetic energy. So they're going to have a higher kinetic energy than the liquid. And pretty much it's high enough that they can overcome any forces that are trying to hold the particles together. So we're going to see a lot of space in between the particles there. Now, if you've got, for the next thing, I'm going to have you mark something out. We're only going to talk about plasma. So if you, particles move freely. Did you get that? I jumped ahead without, that's the last one under gas. We're going to talk about plasma, but we don't need to know about this Bose-Einstein condensates. So you're going to mark that section out. But plasma is matter, we're going to find it in the sun. If you've ever seen the aurora borealis, then you're going to see, you would have seen plasma then. This is matter that has positive and negatively charged particles, and they have the highest, they have an extremely high kinetic energy. And it's actually the most common form of matter in the universe because think about stars, they are huge. And so in comparison with all the stars that exist, it's going to be the most common. It may not be the most common on Earth, but it's the most common in the universe. So you're going to find it in stars, you're going to see it in neon, what we call our neon lights, and the auroras. And then you're going to, on your paper, you're going to mark out the next section, because we're not going to get into that much detail. So if you're on the computer, you can get the drawing tool and kind of scribble out that section. There shouldn't be any questions on that part. I'll stick with plasma. So anything that comes after plasma that starts with the B, you can mark that out. Made up of, stars. Okay. All right, we good?
Yes.
All right, we're gonna get through here. All right, changing states. Changing states does not create new material. This is a physical change. Physical change. This is the result of gaining or losing thermal energy. So if you increase the temperature, you're going to gain thermal energy and you're going to change a state. If you decrease temperature, that means you're going to get cooler. You're going to lose thermal energy and the matter can change state. Physical change. Physical change. If ice melts, it is still H2O. If water freezes, it is still H2O. If water becomes water vapor, it is still H2O. hasn't become something else. It's just changed its form. Heat of fusion is the energy that's needed for a solid to become a liquid. We also, I believe, call this melting. It's kind of like melting. So when you add heat to a solid, it's going to get more kinetic energy. Those particles will gain kinetic energy. They're going to vibrate faster. They're going to start moving faster. They're going to spread apart. And they're going to transition to the liquid state. Then, eventually, if that temperature is still increasing, you may get to heat of vaporization. This is what it is to take a liquid to a gas. We call this boiling. So the amount of energy needed to get a liquid to a gas. So two new terms, heat of fusion related to melting. So you might want to write melting out the side of heat of fusion. Heat of vaporization is like boiling. So you may want to write that out to the side. Okay. All right, you should see, and you don't have to have the different colors, but you should see this here, and you need to label it. All right, so if anytime an arrow is moving from a solid to a liquid, we call it melting. So the arrow that is pointing to the liquid from the solid, oops, write melting on it. Sorry about that. We're going to deal with the red ones first. A liquid going to a gas, we call it vaporization. And then two terms here that you might not be as familiar with. You can actually go from a solid straight to a gas, and that is called sublimation. So label your diagram there. So the red arrows are the ones on the outside. And then you've got the blue arrows on the inside, which is removing energy. So if I go from a liquid to a solid, it's freezing. If I go from a gas to a liquid, it's condensation. And then another term you might not be familiar with, you can go straight from a gas to a solid, and that is deposition. So you're going to need to use that for an assignment that we're going to do in just a minute. So make sure that you get that filled in. I need to back up or you got
No, that's right. I just missed one.
All right, that's going to come in handy in just a minute. So if you, the red represents the outer arrows are representing adding energy. The inner arrows, you're losing energy. Is everybody good? Can I move on from this? You good, Ricky? You good? All right, so vaporization. This is just going from liquid to gas. We're probably used to calling it evaporation, but evaporation is a little bit different. Evaporation is only at the surface. Is only at the surface, where boiling is throughout the liquid. So these bubbles you see within the liquid would be considered boiling, and then anything that is going from the surface out is going to be evaporation. It's just going from a liquid to a gas. Am I good?
Yes.
All right, a heating curve. You've got to be familiar with this. This is showing state transitions. It's showing where a substance is going through heat or energy changes and how it's added. If you notice, going up the y-axis is temperature. So as you go up, more energy is increased. And on the x-axis, it's just saying heat is being absorbed. So on your, oops, did everybody get that filled in? I went too fast, sorry. The top, everybody get the blanks filled in at the top? All right, now we're going to label this chart. This is going to help you on an assignment as well. That first line from 0, or from the intersection here up to 0, this is a solid. And this is on water, by the way. If this was another substance, it might be more above 0. Notice that melting is that flat line. We also can call that heat of fusion, right? I think liquid is the next slanted line. And then we have boiling, which we could also call heat of vaporization. And then you have your gas. I'm going to click one more time and see what happens. Yeah.
Do you write it down?
Yes, you need to know that those are interchangeable there. So if you have done these on your paper, you need to submit the blank copy that's on the computer. And I'll try to get them entered today, so it won't even matter, but, and still, if you will submit it, it would be helpful. And then, we'll get some, hold on. We get hole punch. I'm sorry.
On the right, you
Hole punch that. All right, so if I got this. We good? All right, so that's your notes, so I'm gonna get out of this.
Yeah.
And,
It didn't help much.
hold on, I'll get it.
Uh-huh.
It's on. All right, we are going to, there is a video here that you'll need to watch, and then here's the phase change graph. And I'm gonna give you you got it, I'm gonna give you a paper copy. Back there. So there's Ed Puzzle video, and then there is this right here. So using your notes, using the information that's on this sheet, you are going to fill in this bottom part on the front, so let's look at it. And you should already know this. So melting, you're gonna change from what?
So it's liquid.
Okay.
Wait, is that right?
Yeah.
Wait, what is that? Solid to liquid.
Freezing, you're changing from
Liquid to solid.
liquid to solid.
Well, yeah, I can use.
I got a something. A pen.
You don't have your,
Pencil pouch.
oh, here's your pencils that are here. Here's the first pieces.
Let's just break these.
Right, evaporation. Is what? Or vaporization?
Liquid to gas.
Liquid to gas. And that little triangle we filled in will help you. Condensation is
Gas to liquid.
gas to liquid. Sublimation,
Solid to gas.
solid to gas. And deposition,
Gas is solid.
gas to solid. Now, what is up here on the back of your sheet is similar to the triangle. So if you have your notes, you want to look at that triangle page. Except it's not in a triangle, because it's arranged a little bit different. But follow the arrows. So for like number 1, the arrow is going from solid to liquid. So if you go from solid to liquid, what are you going to put at number 1?
Melting low.
Melting. So number 2, liquid to solid is what?
Freezing?
Freezing. So see how you're doing that?
Yeah.
So you can finish that one on your own. And then if you look at the bottom part, you're going to use the graph in the notes on the last page to fill in each part. Now notice A, C, and E are already labeled because it's solid, liquid, gas. And so you're going to label 10, 11, 8, 9. Don't worry about the arrows that are drawn there. I want you to put the 2 terms that we put for that spot. Don't worry about the arrows for B and D. And
Are you gonna
then,
check this with us?
and mark out number 7 on that chart. Mark out 7 down here.
That's it.
That's not what's going right there.
Yes, but there's nothing down there. Don't worry about that because it's already on there. Oh, heat absorbed. Yeah, heat absorbed. Very good, thank you. Never mind, it's all on the chart. So you're gonna use the note, where's the notes in this note? So this is gonna get you fill this in. This helps you fill in this, right there. Fill that in using that chart. And then if you're doing it on paper, you click submit and submit it blank. And then I will get it from the paper. If you're doing it on computer, make sure you submit it. When you're finished with that, you need to, you may or may not get finished before the bell rings. There is an Ed Puzzle video. And make sure that you have, you pay attention up here. All missing work is due February 12th. Anything missing, if you want credit for it, it is due February 12th. Now, I'm available to stay some in the afternoons, most afternoons, for at least 45 minutes if people need to stay to get caught up. You are welcome to make arrangements with me to do that.